Hello everyone, welcome to the class. So in this class we will solve one RL first order circuit in using differential equations, right? So in the previous lecture, that is L3, we have seen the basics of RL circuit, first order circuit, right? So let's solve this. Okay, so in this question, there is a switch which at t is equal to 0 moved to position number B. So at position A it was there for a long time, right? And after that at t equal to 0 it was switched to position number B, right? Okay, so there is like resistor R1 and there are components like L1, R2 and L2, right? And what we need to do is we need to find out, actually we need to sketch I1, I2, V2, right, for t greater than equal to 0, right? Means after switching we need to find out these parameters. Okay, so let's solve what was happening at t less than 0, means before switching what was going on. Okay, let's draw the circuit. So before switching, the switch S was at position A for a long time. It means the steady state has been achieved, right? So this is R1 resistance, its value was 1 ohm, and this is 1 volts, 1 ohm. Okay. So in the steady state, as we know that the inductor would act as short circuit. It means in the steady state the voltage difference across this inductor will become 0. That's why it acts as a short circuit, right? So let me draw like this way, 2 points. It is acting as a short circuit. Okay, so what is the current? I1, right? Okay, this is 1 ohm and this is 1 volt. So it is simple, like I1 would be, I1 actually 0 minus would be 1 upon 1 ampere, right? This is very straightforward. Okay, so this information we need to have for solving the circuit at t greater than equal to 0, right? Okay, so this will become actually the initial condition. Okay, now when the switch was moved to position B, right? Okay, so here it was given like this is V2. That's why this node will also become V2, because all these three components are in parallel. And here it was like I1, this was I2, this was R2, L1 and L2, right? Okay, so I1, what was given? I1 0 minus is equal to 1. I'm not writing the units. So I1 0 plus, after switching it will become like 1 ampere, because the conductor does not allow the inductor does not allow sudden change of current, right? Okay, so we will apply a KCL because these three are in parallel, right? One equation would be sufficient. So I1 plus V2 by R2 plus I of 2 would be equal to 0. And what is I1? Okay, so this voltage V2 is parallel to applied parallel to all the three components, right? Okay, so if I need to write, so V2 would become L1 di1 by dt, right? And V2 will also be L2 di2 by dt, right? So this will give you I1 is equal to 1 by L1 integration of minus infinity to t V2 dt, and similarly I2 would become 1 by L2 minus infinity to t V2 dt, right? So far so good. Okay, so let's put this one in. Okay, let me write this as equation number 1. So what is I1? So I1 would be 1 by L1 minus infinity to t V2 dt plus V2 by R2 plus, just a minute, 1 by L2, right, minus infinity to t V2 dt. So if you note the equations, it is just similar to the capacitor ones, right? There it was like we were integrating the current, right, instead of voltage. Anyways, let's go for it. Okay, so now we have got this equation, and everywhere there is like V2, right? This, wait, let me, okay, this V2 is here, V2, so only one variable is left, right? So we can solve this for V2. This will give the solution for V2. So instead of solving the integration, let's differentiate the equation. So this will become V2 by L1 plus d V2 by dR2, sorry, it's not R2 actually, d by dt of will be like 1 by R2 plus this would be V2 by L2 is equal to 0. Now you see it has become first order equation, dV2 by dt plus R2, actually I'm directly simplifying it, V2 1 by L1 plus 1 by L2 is equal to 0. So I can write it dV2 by dt plus V2 upon, this would be like R2 and L1 L2 to L1 plus L2. Actually I simplified this one directly, right? Okay, now if you solve this equation, we will get V2 will be a of e की power minus this R2 upon L1 L2 upon L1 plus L2 into t, right? Now we can put the values and see what are we getting. Okay, before solving this one, let's find out the value of a. And as we know that even in the previous class also, we if there is a constant associated with this exponential term, means actually this is a natural response. So to find out the value of this constant a, we need the initial condition value, right? So let's go for initial condition. Because why we need initial condition? Because e की power t is there, right? Some constant and t is there. So at t is equal to 0, this will become 1, right? So this expression will become 1. This one will become, wait, this expression will become 1. We will be left only with a. That's why we need at t equal to 0, right? So at t is equal to 0 plus let's draw. Is it the case? See, this was like 1 ampere at t is equal to 0 plus. I am drawing this circuit exactly at t is equal to 0 plus, just after the switching. So this was 1 ampere, right? This was I1, right? And again the inductor 2, this was like L2, right? So there was no initial condition associated with this inductor 2, so there is no current. So even after switching there would be no current, and if there is no current, I can replace it with an open circuit, right? See, and this was like V2. We need to find out V2 0 plus, right? So what will happen? See, all this current will pass through this one, right, this way. So if I need to draw, like, let me like this way, this one this way, right? Okay, so here V2 will become remember the polarity, right? It will become 1 into, okay, this was like R2 now, this was like R2, like 1 into R2 with a minus sign, right? So it will become minus 0. Okay, R2 was 0.5 ohm, so it will become 0.5 volts minus sign. Why minus? Because we have polarity, like the top part was positive terminal and the bottom part was negative terminal, but the current was going against it, right? Like this way, so it will become minus. That I need not to explain, that is very simple basics, right? Okay, so V2, basically this is what, this is V2 of 0 plus, right, at t is equal to 0 plus. Now we have to put this value, means we will put this value here, right? So at 2 is equal to 0, it was minus 0 0.5, right? A and e की power 0 is, and a is equal to minus 0 0.5 volts actually, right? So we can write it V2 of t minus 0 0.5 e की power. Okay, just one more thing, let's solve this R1, this time constant formula. What is the value? Okay, let me write it here again. R2 upon, there are so many things actually in the solving a circuit, right, into t. So what is R2? R2 is like 0 0.5 ohms. What is L1? 1 into 2, right? 1 into 2, and again this will go up and this will become 1 plus 2. So what will come like, okay, 1 2 3, 3 by 4, is it okay? 3 by 4, right? 0.5 नीचे गया 2 4, okay, this will be like 3 4. So the final expression would be, if you have already solved, just skip this part and you can minus 3 by 4 into t, right? Okay, so this is the V2 part. So definitely it says that V2 will start from a minus 0 0.5 volt, and it will at t is equal to infinite time, it will be like vanished completely, zero, right? It means definitely what I can say, that here if you see, right, so V2 at t is equal to infinite, here it is a 0 volts, right? At infinite 0 volts, because this is 0 volts, right? So 0 volt means no current would pass through this resistor. Let's see what will happen across these inductors, right? At least the current is not passing through the resistor, right? Because I into R is equal to V across R, and again this voltage is becoming 0, it means I is becoming 0, right? Resistor is not going to be 0, the current flowing through this resistor is going to be 0, right? Okay, now we have found out actually the value of V2. Now let's find I1 and I2. Okay, this I1, so the I1 be like 1 by L1, right, minus infinity to t V2 of t dt. So okay, and let's break this part, 1 by L1 minus infinity to 0 V2 t dt plus 1 by L2 0 to t V2 of t dt. Now, okay, so this is like initial condition part, and this is the response we need to, right? This is after initial condition, means after switching. After switching, right? This was like before switching. And we know its value. Let me scroll up. It was, I think, 1 ampere, right? 1 ampere. this will be like 1. I'm not writing the units. Okay, this will be like 1 by L2. So L2 is again, oh sorry, this is not L2 na. Wait, this is L1. I'm writing for L1. And L1 was like 1 Henry. So this will become 1, 0 से t, and this is minus 0.5 e की power minus 3 by 4 into t dt. Now it is a matter of solving the just integral equation, right? So minus 0.5 and again minus 3 by 4 e की power minus 3 by 4 t, 0 से t. Okay, 1 minus minus cancel, plus 2 by 3, 4 will go multiply by 1.5, it will 2. Okay, power minus 3 by 4 t minus 1, because e की power 0 will become 1. Okay, so this would be like 1 minus 2 by 3, right? 2 by 3 plus 2 by 3 e की power minus 3 by 4. Fine. This will become 1 by 3 plus 2 by 3 e की power minus 3 by 4 into t, right? So this was like, okay, I got I of 1 t. Let me just put it in a box just to highlight. Okay, so just cross verify it. At t equal to 0 I need 1, right, at 1 ampere. So at t is equal to 0, 2 by 3 plus 1 by 3 will be equal to 1. Okay, at in the steady state it will be 1 by 3 ampere. Okay, in the steady state it will reach 1 by 3 ampere. Okay, so see again what I am in this circuit. This is L2, this is L1. So it started with 1 ampere at t is equal to 0 plus, and in the steady state it will reach 1 by 3, right? This I1, right? So in the steady state it will reach 1 by 3 ampere. No current will flow through this resistor because V2 was going 0. So okay, so what will happen, all the current will go through this one, like, right? So okay, for this I2 also, for I2 also in the steady state we will get minus 1 by 3, right? Okay, let's see what happens. Okay, so for I2 of t, it was like 1 by L2 minus infinity to t V2 of t dt, right? So L2 is like 1 by 2. Anyways, first of all, let me go for this initial conditions, is there or not. 1 by L2 minus infinity to 0 V2 dt plus 1 by L2 0 to t V2 of t dt. Now you can see this part is initial condition point, and it has to be 0 because there was no initial condition, no initial current was flowing through the inductor L2, right? So we have to solve only this part. Okay, so 1 by L2 is like 2 Henry, right? 0 से t minus 0.5 e to the power minus 3 by 4 t dt, right? And this is 1 by 2 minus 0.5 e to the power minus 3 by 4 t divided by minus 3 by 4, right? And this is 0 to t. So minus minus sign cancel. 4 2 1 1 by 3. This 2 times and this 2.5 के ऊपर 1 हो जाएगा, and e की power minus 3t minus 1. Okay, so I of 2 of t would be minus 1 by 3 plus 1 by 3 e की power minus 3t. Okay, So if you see at t is equal to 0 it is like 0, and at t is equal to infinity is minus 1 by 3. Okay, fine, that is okay. This minus 1 by 3 is fine. Okay, 1 by 3. So why minus 1 by 3? So don't get confused, right? Here, okay, here it is minus 1 by 3 in the steady state. So in the steady state actually what is happening, so let me draw the circuit here to explain. This was at t is equal to 0 plus, right? This was 1 ampere, this was R2, and no current was flowing through this. Now at t is equal to, no current was flowing through the resistor. Now you see at t is equal to infinity, this is 1 by 3 and this is 1 by 3. Look at the arrow. Now the thing is that we have defined the direction of current like this, I1 and I2. So definitely I2 has to be minus 1 by 3, right? Because whatever current is flowing at this, means I'm talking about the steady state, here all the current has to pass through this inductor L2, right? And because no current is flowing through this one, and if no current is flowing through this one, it means the voltage V2 is all would be 0. V2 at infinity is 0 volt. So all these conditions are satisfying. It means whatever we have solved is correct, right? So this is how we should cross check also, if you want to cross check, and I would request my audience to just cross check whatever you are solving, right? So many times we just miscalculate the time constant, or we do some mistake in solving the integration. Sometimes some constants are missing, right? Or maybe we have picked up some wrong value of R or L, that's why. But at the end, see, if you see at t is equal to infinity, everything is satisfying, right? Current here, 1 by 3, 1 by 3. So if you see, this is minus 1 by 3, it has to be minus 1 by 3, it cannot be plus 1 by 3, right? And here it also, it is like 1 by 3, right? So if I need to draw the means sketch, actually if I need to sketch it, let's sketch all the parts. So this one was like V2 we have started from, okay, this was started from minus, I'm sorry, wait, actually this is T, this is V2 of T, and it was like minus 0.5 volts, and it was dying out, right, like this way. Okay, now let's go for the current. What is I1? I1 started from 1, and 1 by 3, this was 1, and this is 1 by 3. So it will go like this, just like the capacitor. The response will be sandwiched between the initial and the final condition. So this is like 1 by 3 ampere, this is 1 ampere, right? And if I need to draw the value of I2, right? So I2 was starting from 0 and it was going to minus 1 by 3. Suppose this is I2 in the same graph. If this is I2 also, if this, suppose this also represent I2, okay, let me take a different color. Green would be better. Okay, let's say I2, right? I2 was starting from 0 and it was going to be minus 1 by 3. Let's say this is minus 1 by 3 ampere, right? Okay, so basically at t is equal to infinity, infinite state, I1 was equal to minus of I2, right? So this we have sketched. Okay, fine. So I request you to solve this circuit at your own, right? And if you have problem, please drop the comments. So in the next lecture we will solve some more problems regarding this first order RL circuit, right? But there we will not use any differential equation, because suppose there are multiple means resistors are there or and inductors are there, so solving differential equation would be very long, until and unless exam in your exam it has been asked that you have to solve using differential equation. So don't use this differential equation method. If it is a first order circuit, then blindly go for the initial condition at final condition and find out the time constant, and you can directly draw the graph. So you can see, you can draw this kind of graph, right, just by knowing the initial final condition, means the steady state, the initial condition and the time constant, right? Thank you.